Hey friends, if you're watching this, this is going to be a faster video than usual. If you want to practice and you're watching this for the first time because you weren't in class, you need to take the appropriate time to pause. I'm going to be going through this faster. You need to pause this on your own though. At times where you need to review, you need to rewind the video and listen to my explanations. Okay. Do now questions. Shoot me with the shoot me up with a DM in maybe whatever you call it, email or Google Hangouts. I'd love to find out about what your creative interests are. I often find those much more interesting than professional interests. That's just my personal opinion. Last class we talked about Lewis structures of molecules. So we upgraded from just like a singular H atom or a singular O atom, and we said, hey, what if we combine them? H, O, H, our good friend water here. What about carbon dioxide? Carbon with two oxygens. We learned all about, okay, how do I combine all the electrons together to make these? Today, we are going to be interpreting different Lewis structures and doing some counting practice. And then part two is going to be the 2.1 final assessment, which will be the majority of class. Exit ticket review. This is drawing a Lewis structure for lithium dioxide. Sorry, Li2O, not lithium dioxide, dilithium oxide. So each lithium atom here brings one electron with it. O brings six valence electrons, and therefore I need to take the one electron from lithium and bond it to O, so that O ends up with 8. Therefore, which is a little typo here, it meets the octet rule. If we count oxygen right here, 1, 2, 3, 4, 5, 6, 7, 8. If you're good on this, you can probably skip the next part of the video where I go through a little bit slower. What does this actually look like? I'm going to draw before things are bonded over here. Before everything is bonded, I start with one lithium atom, and then I start with another lithium atom, because I know that it's Li2O. The molecule we have is Li2O. The 2 comes after the Li, so there's two of them. And now I've got an O. And on this O, I've got 6 valence electrons. And we get that from the periodic table, given what column it is on the periodic table. So this is before it bonds. After it bonds, the single electrons link up with one another. And after these all link up, we get what we see here. The two electrons link up and they become bonds, sticks, which represent two electrons. These electrons are now shared. So lithium has access to these two electrons. Lithium has access to these two electrons, and oxygen has access to both of the bonds and all of its single electrons that it's keeping to itself. It's not sharing these. Okay. So there is now time for a week 6 homework review where we're going to take 5 minutes. You're going to pull up your week 6 homework and you are going to use the answer key that's attached to this assignment. It just says answer key. You're going to leave a private comment with how many mistakes you made. This is not going to affect your final grade. If you never started the week 6 homework, leave a private comment on the week 6 homework and tell me, why didn't you start that? I really honestly want to know. I'm not here to be angry. I'm not here to be like, why didn't you start it? I want to know what's going on in your life. Like, do you need more reminders? Is it that you forgot? Is it that something's going on at home? Like, tell me whatever. I'm here for you, honestly. Getting into some counting practice. So again, this is that time where like you need to pause because I'm just going to run through the explanations on these. So you need to pause on these and practice before I do them. So pause now. Ammonia. How many of each atom are present? One nitrogen atom, three hydrogen atoms. How many bonded electrons? Well, we need to answer how many bonds first. 1, 2, 3 bonds. Each bond is worth 2, so 6 bonded electrons. How many non-bonded electrons? 1, 2, 2 non-bonded. So this is 6, this is 2, this is 1 nitrogen, 3 hydrogens. Ammonia is used as a cleaning agent. So if you're ever like, ooh, I need something that smells lemony fresh, ammonia doesn't sell lemony fresh, but you can get it with a little bit of lemony smelling molecules mixed into the solution of ammonia that'll help you clean your floors. Great for cleaning tile. Formaldehyde, again, pause now. Formaldehyde, we can see from the formula here. Let's try and also use this formula, not just right here, because right here it's pretty obvious. One carbon, two hydrogens, one oxygen. Over here, there's no one with these carbons and oxygens. The one is sort of implied. So we say there's one carbon, there's two hydrogens, and there's one oxygen. How many bonded electrons? There's 1, 2, 3, 4, a double bond here. 8 total electrons in the bonds, since there are 4 bonds, and each is worth 2. Non-bonded electrons, 1, 2, 3, 4. 4 non-bonded electrons. There's 2 pairs of non-bonded electrons, two pairs. And we call these lone pairs. Lone pairs and non-bonded pairs mean the same thing. Formaldehyde is used as a preservative. If you are trying to preserve any sort of thing that would decay naturally, like this swordfish. This swordfish would usually be like a rotting hunk of mess inside of the Natural History Museum, but we have preserved it in formaldehyde. Formaldehyde's a great preserving agent. That's how they preserve, well, something similar to formaldehyde is how they preserved ancient mummies and the flesh that was used for them. Cool, let's talk about ethanol now. Pause again. All right, counting. Using the formula, there's 2 carbons, 6 hydrogens, 1 oxygen, since there's nothing here. Using the picture, the Lewis diagram, we count the same number of hydrogens, 6, 2 carbons, 1 oxygen. How many bonded electrons? Let's count how many bonds there are. 1, 2, 3, 4, 5, 6, 7, 8. 8 bonds. So there's 16 bonded electrons. Each bond is worth 2. So this oxygen and hydrogen sharing 2 electrons right here. This oxygen and carbon sharing 2 electrons right here. Non-bonded electrons, there's 2 lone pairs, meaning that there are 4 non-bonded electrons. Ethanol is what we say when we talk about alcohol. Ethanol is what is alcohol. Alcohol is generally a more, we're going to learn about alcohol in chemistry to mean a more general thing. Means that molecules that have this kind of pattern right here. There's a carbon bonded to an oxygen, bonded to a hydrogen. That is what it means in chemistry. But when you hear it in the real world, well, in the real world, chemistry is the real world. Alcohol is just alcohol. Ethanol is one type of alcohol. It's important to know that it's a difference between like a standard drink. A lot of people will pour wine glasses that are the size of beer, and they'll overdrink, and that is a bad way to get alcoholism or alcohol poisoning. That is very dangerous to your body. Alcohol abuse is something that runs in my family, and I just want you to be aware of it, that you don't end up with an alcohol abuse problem later in your life. Super important for that. If you ever feel bad about a situation that might involve drug abuse or drug dependence, whether it's with you or with a family member, I'm a safe person to talk to. Just letting you know that, because I have family members who have been in addiction, and it's a very hard thing to see, but it is something that, there are services out there for people. So just letting you know. Okay, here is a dragging, which you can't do if you're watching the video. So pause and tell me which one you think is propane. It's either the left or the right. So C3H8, ooh, there's an oxygen right here. It's probably not this. And let's count. 3 hydrogens, 3 carbons, 8 hydrogens. Yep, propane. It's on the right here. This is not propane. So we're saying dragging. So which one of these formulas now, is it this formula or this formula that matches with this? And if we count again, 2 carbons, so can't be this one already. This one doesn't have a 2 here. This one's got a 2 here. So it's 2 carbons, 1, 2, 3, 4, 4 hydrogens, yep, and 1 oxygen. This thing is called epoxide. It's generally what makes glue sticky. Methanol. Look, methanol, this is another type of alcohol. That's probably going to give you a hint. So again, we remember how I said that there's like an O bonded to an H bonded to a carbon. That's what an alcohol is. Another way to say is like, ooh, there's an O here. There's no O in this molecule over here. This is not methanol. This is methane, an explosive gas, which is a big greenhouse contributor in our environment. I want to give a shout out to Angel Guallpa with like a really, really great question. He DM'd me this question because we were working on some stuff, and he really just blew me away with this. So he said, like, I've noticed, and I'm paraphrasing here. I've noticed that some atoms can pair up to form molecules, and examples that we've seen already is like Br2, Cl2, F2, O2. And he asks, can all atoms pair with themselves? And that's something that I propose back to you because I think it's a great question. This is not something that I was actually planning on teaching, but Angel got a good question. And I want to teach it. Draw a Lewis diagram for Br2. I want you to do that. And I want you to try and draw a Lewis diagram for Ga2. You're going to need to pull up a periodic table to do this. So what you'll realize with Ga2 is I'm going to show you on a whiteboard right now. And I'm going to just move this over. So Ga is in the third column. So Ga, each Ga gets 3 valence electrons. And we remember with our octet rule, means that like 8 is great, right? So right now, this thing's got 3, this thing's got 3. Maybe if I try and like bond them together, I can share more electrons and then it'll be happy. Let me try doing that. So let's replace those now with a new drawing down here. And let's say like, okay, sorry, Ga, and I'm going to replace this one with a bond. So I'm going to bond it to Ga. And now I can't get rid of my electrons. And now let's say like, okay, are these happy now? Well, let's count. 1, 2, 3, 4. Okay, this gallium's got 4. 1, 2, 3, 4. This gallium's also got 4. That's not going to help us. We can try bonding this. But you might be able to make a prediction that that's not going to get us there. Maybe if we also bond these two. Let's see if what happens if we bond as many as we possibly can. We're just going to bond as many as we possibly can here. So we started with 1 bond. Now we're adding 2 more bonds. So here's the original bond. Here's bond from the electrons going up top. Here's the bond from the electrons going down below. This is a triple bond, something that is feasible, but something that's not going to quite get us there. Let's count now. We've used up all of our electrons here. Gallium, it's only got 6 electrons. It's got its 3, and it's shared its 3 with this over here. So there's only 6 valence electrons over here. 6 valence electrons over here. It's not doing it, folks. Ga2, this is a G, Ga2, that molecule does not exist. Why does it not exist? Because 6 valence electrons is all you can get. Even with sharing, if they share all 3 with each other, that's as most as they're going to get. Going back to our slideshow, I think this is now where we have a break. And then I'm going to show you that on the final assessment here, there will be a link to the YouTube instructions. If you don't watch those, you will not be able to do this. So watch those instructions. That's it for me. There will be a link here. I haven't put the link in yet. It's because I'm uploading the video now. That is it from me. Let me stop sharing my screen. New share? Where's just no share? Okay, I just want to wave bye. Let me just do this. Bye. Later, folks. Oh, stop share. Haha, there we go. Later, friends.